Somebody was calling me. Oh, so our stems should look like, I'm sorry, say again. What's the lowest number up there? Or yeah, 100 in the teens, right? 14? So we didn't want a stem like 1, 1, and then the next numeral would represent the ones place.
Yeah.
The leaves would represent the ones place. So do you see how much flexibility you have with creating a 7-leaf plot? You make it fit the data. What makes sense? If my data was 1.78, 2.93, my stems could be 1, 2, 3, and then my leaves could be 7, 8. So that 178 would be 1.78. Now how do I make that clear to somebody? I put a key, and I say 1, 1. What's the lowest 1, 1 looks like?
114.
114?
Yeah.
114 means 114, because this could mean 11.4. Do you guys see that? This could mean 11.4. It could mean a few different things. I gotta let people know that means 114. And real quick, like I said, this book likes semi-weird topics like strontium levels in baby teeth. That's kind of disturbing. So go ahead and try to make a 7-leaf plot out of that data. All right, you might be getting some of the homework done right now. Oh, there. Already done 11. I would say to sort this thing would be a huge advantage. Not too excited. I wasn't planning on this problem from the beginning, to say honestly. I'm thinking about it. Anybody else need the Calculator Bible? Handout I gave out that has all the procedures. Everybody's got that? What's that? Really back curl?
It's right there. Down. Down. Below that. The line. Up. That line. To the right.
Oh, millibecquerel. That's just the units they use. Yeah. Sort of like milli. I think y'all know what milli is. The becquerel is just like a foot for length becquerels for radiation amounts.
Okay.
Not just for baby teeth, but for anything. Rads are what we used to. It's the radiation thing. But here they decided to use something else. Just to kind of cut to the chase a little bit. Have you guys all got that data written down?
Just wait, man.
Mm-hmm.
Yeah. Stat. Number 5 should say setup editor. Enter and then go back in.
How should leaves go from like 0 to 50 or making stuff like 5?
You want to put 1 step down?
Oh, they have to be in order.
Yeah.
Because you do want it to, if you turn sideways, it could represent like a histogram. And the histogram requires a true scale in order, right? So not only, you want this to be a quick visual of your data, and if you put the data out of order, it's not an accurate visual. Does it make sense?
Like your stems can be ordered from like 11.
Oh, I see. But your
Like
leaves,
your leaves,
they don't have to be.
They don't have to
If they are, it just makes, if you have other stuff to do with the data, it would make it easier, but they don't have to be for the plot. Because then the shape would be the same. Right. All right, just to cut to the chase. Hopefully, most of you guys have kind of started in the first few entries in your stem plot. Here's what it would look like at the end. Not that. Not that. I appreciate that so much. No, I should have stayed where I was. I just had it frozen, didn't I? Unfreeze. There you go. Here. So what can you tell me about that distribution? It's not a true histogram, but what can you tell me about that distribution? It looks to be bell-shaped. You go like that. There's your quick visual of the data. Looks to be bell-shaped. Here they put it in order, but it doesn't have to be. Cool. These have to be in order. Obviously, these don't, just to get the shape. Okay. So do you think that section is going to be very difficult? It should not be. Let me point out a few things in this section. Just so you're not freaking out when you go to read through this, as I know you all do. We will not be talking about frequency polygons, because they are very rarely, if ever, used. We will not be talking about, even though they have a cool name, ogives. We'll only be doing dot plots, stem plots. Bar graphs, we already kind of know. That's the qualitative analog of histograms. A bar graph is if my data is just like this. If my data is just names, so that's good. If my data is just names, this is a bar graph. Notice how a bar graph is allowed to have gaps, because it's not a true scale then, it's just names down there. But you're not going to have any bar graph questions. The last one I'm going to talk about is scatter plot. And all a scatter plot is an XY plot. So if I went outside and I said at 9 a.m. it was 62 degrees. At 9:30, it was 64 degrees. At 10 a.m. it was 70 degrees. 10:30 it was 72 degrees. Couldn't I plot those?
Yeah.
X, Y? That's what they mean by scattered plot. It's scattered, right? But it might have, now I would expect temperature from the morning to noon should have what shape?
Up into the right.
Basically should have some kind of upward trend, right? Depending on the region of the country, it would probably be a shape like that, a little bit of a curve, and then sometimes it's going to reach its maximum and then come back down. And then the next day it's going to go up and then come back down, and then it might go higher, and that could be over the course of a week. Or does anybody surf or kayak? I kayak, so I like to see what the surf's going to be like. So if you go to Scripps, they have a really cool thing where they tell you what it's going to be. I'm making myself seasick. And they show you when the peak is, when it's lowest, if you want to go tidal, pooling, right, is that how we call it? And then it's the same thing, right? You can kind of take measurements, so they show you what actually happened and they predict what is going to happen. And it's, it's kind of cool to see that. Okay. Oh, cool, perfect. So I did want to let you guys out early. The last little thing I want to talk about, Section 2.5. And here's an example that really captures the heart of Section 2.5. And we'll get out of here a little early. The person or group that made this graph, so this was, I like the reference to something that happened a long time ago. You guys, and I still don't know how to pronounce this person's last name, but Terry Schiavo, yeah. Schiavo? Is that how you say it? Okay. Terry Schiavo, where it should have been a personal decision by the family, but it became this national, feud over You must not. You must do it. You must not do it. No, it's their freaking decision. Leave them alone. I hate that crap. You guys remember that at all?
Yeah.
Or is that too long ago? You're too young. Do you agree with the court's decision to have the feeding tube removed? And what they did. Now look at this. Democrats, evil, because they want to kill this person, and the Republicans and Independents, we don't want you to. Right. So this is trying to represent what? I just kind of made the point for you, but this is trying to show you that Democrats are just crazy out of touch. Oh my God. Right? What did they do? Now there's an accurate representation. It's the same data. What's the big difference between those two graphs? This one doesn't start at 0, that one does. So the difference in heights looks to be relatively a lot more pronounced here than it does over there. So this whole section is about what did they do wrong with the way they graphed this? Can you regraph it in a better way? So they'll give you this, what's wrong with it? You say this is wrong with it, and then you regraph it. You should read the section because there is some stuff about if you use little oil barrels to represent amounts of oil used or something. It's not cool to use three-dimensional graphs because that overstates the problem too. So there are little things to worry about otherwise. But most of your homework should be, what's wrong with it? Can you redo it?
Could you also do a spin campaign? That one on the left is a lot better.
Exactly. So this is why people don't like statistics, but it's just because the more educated we all are about statistics, the more we catch this and discard it. The less educated we are, which unfortunately a lot of people don't know shit about statistics, they'll look at this and go, oh my God. And that'll inform them as to how to vote or something. Right? Because both parties and both political activity committees, they do the same thing both ways. To try to spin everything in their direction. Okay, that's enough. So next week I'll have this quiz. Don't forget, we have a quiz. Oh, sorry. Quiz on the histogram stuff. Cool.
For the barrels, I'm not too sure why it's misrepresenting it because a liter is three-dimensional. So a gallon is three-dimensional. A barrel is three-dimensional.
But if you're talking about like the point they're trying to make is what happens a lot with this is if you say, okay, they did twice as much, these guys did twice as much, they double the radius or something. They double the radius and they double the height.
Oh, so they double the height and the radius.
They make it, they double everything actually, which in the end the volume is going to be increased by a factor of 8. So it's a misrepresentation of how much more or less the other thing is. If you use a 3D object.
No, I'll wait. All right.
Can I get the